Hello and welcome to the MV Switchgear podcast. And today we will talking about our first topic on our calendar, introduction to MV Switchgear. Eben,
Yes, good morning.
will you quickly take us through the calendar and the topics we will be discussing this year?
Sure thing. So on our calendar, which you all received, you can see that the normal calendar on the one side. On the other side, you will see some interesting topics. And the first one that we're going to cover today, and the first one which we're going to air in January, is the introduction to MV Switchgear, which is an overview of what switchgear is and what is the importance in the electrical distribution system. In February, we'll speak about the types of MV switchgear, explore different types, such as air-insulated switchgear and gas-insulated switchgear. And then in March, we will discuss the key components of MV switchgear, components like circuit breakers, disconnectors, relays, and more. And then the next one is then in April, which we're going to cover switchgear testing and maintenance. That's quite a large one. We will highlight the importance of regular testing and maintenance of MV switchgear to ensure safety and reliability. In May, we will do the MV switchgear safety protocols, explaining safety measures, personal protective equipment, and best practices when working with MV switchgear. In June, arc flash hazards in MV switchgear, dive into the risks associated with arc flashes and strategies to mitigate them. That's quite an explosive topic as well. MV switchgear design principles. Explore the fundamentals and principles and considerations when designing MV switchgear installations. This one will be a meaty subject. And then in August, we will do advancements in MV switchgear technology, latest technology, innovations and trends in switchgear. There's quite a lot of industry updates on that connected switchgear. And then in September, we'll do the switchgear for renewable energy, explore the role of switchgear in renewable energy systems like solar and wind farms. In October, we will cover switchgear in industrial applications, highlight the use of MV switchgear in various industrial settings, including factories and plants. November, we will do case studies of real-world applications and sharing real-world examples and success stories of MV switchgear installations and their impact. And then we will do the last one in December, regulations and standards for MV switchgear. This one will be for the engineers and the technical guys out there. I think a lot of people need some basic simplified information of the high intensity topic of regulations and standards for MV switchgear, particularly for the IEC markets. And that's it for 2024.
Okay, Eben, so let's start off with today's topic then. What is MV switchgear?
Great stuff, yeah. So a lot of people, when we tell them, look, we're working with MV switchgear, the first thing they say, what is switchgear? And what is MV? So MV is a field of voltage which we describe starting from 1000 volts and then reaching about 40,000 volts. But the rated currents that we normally use is 6,600, 11,000 volts, and then 22,000 and 33,000 volts in South Africa. In other countries, it can be similar to this, 12,000, 15,000, and 36,000 volts. So it depends on which country you are in, but that is the field which the industry calls the medium voltage field. Then what is switchgear? If you go into a house and you plug in something faulty, there will be a switch that trips in your distribution board, and that is all switchgear. Your light fittings is a switchgear. Even your plug fittings, where you put in your plug and you switch it on and off, that is all switchgear. So switchgear is actually a very, very wide field of anything that can break, open and close on your electrical network, and that is what switchgear is.
Okay, cool. Where will your MV switchgear fit in?
Okay, so obviously you can't use an MV switchgear which is almost your size or and even sometimes much bigger You will not use it in your house to switch on your lights. You want to use a small thing for low current, low voltage, and then you want to use the big stuff where it matters. So on 11 kV or MV networks, you have a fault rating which is a bit higher, and then you also have a very high, what they call energy rating. So for a small low voltage application, you will not generate a lot of energy when it flashes. But in medium voltage applications, you can create a lot of energy. So what they need is something that can handle that can break it safely. So where MV switchgear fits is basically between your transmission and sub-transmission voltages, and then your household voltages and factory voltage are 400 volts. So 11 kV is used outside of your houses. You will find there's either a mini substation or a transformer on a pole or something like that. That transformer steps down from 11 kV, from 11,000 volts, down to 400 volts, which is then distributed in the network to your houses or to the factory where you operate. And so that switchgear fits into that space, protecting the transformer, protecting the transmission lines, protecting the cables and the network of that.
Okay, great stuff. So even tell us more about the discrimination in tripping.
Yeah, so we spoke about plugging in something into into the wall. A plug, you're plugging in a kettle or a iron or anything that you can think of. And now that thing is faulty. That equipment that you just plugged in is faulty, and now there's an overcurrent that's being created. Now, where do you want that overcurrent to trip? Do you want it to trip as close as possible to it, or do you want to trip out the whole town? So discrimination and cascading in switchgear says that we want to contain the fault as close as possible to the source. So it will say that this one will trip on, let's say, 10 amps before the next one on 100 amps will trip, before the next one on 1,000 amps will trip. So that when you have a small fault, the first line of defense will trip. Because you can imagine if you plug in something faulty and it takes out the whole neighborhood, not everyone is not going to like you very much.
Yeah.
So switchgear have got the job of discriminating the fault down to the smallest piece of outage. And that helps to keep the whole system safe and reliable and stable.
Okay, great. And that also helps to protect the humans and the plant that it's feeding power to.
That's correct. So when you set up your protection in your MV switchgear, you always set it up in such a way that it will adhere to the safety limits of your equipment. So let's say you have a piece of cable and the maximum normal rated amps that it can operate at is 200 amps. You're going to set your protection settings very close but below that. So that when it goes over that, you will then trip out to protect this cable, because if the cable starts getting hot, it will melt, the insulation will collapse and it will flash, and then you've got an outage. So protection has got several roles. When it fails, it will trip out as fast as possible to protect the plant or to protect the human, and then secondly, it will also protect that cable from overheating in the first place, from overcurrent, from pulling too much load.
Yes. Okay, great. And even tell us more about the speed and reliability in MV switchgear.
Okay, so it is very important that the switchgear must last for many, many years. So it doesn't help us if you buy a piece of equipment that feeds a whole town and it only lasts 3 or 4 months, and you have to replace it every 4 months, creating a week-long outage. So what you want is switchgear that is very reliable. Now, in the market, you will find cheap and nasty, you will find nasty and nasty, and then you will find more of your reliable suppliers. We prefer working with the reliable suppliers and using their equipment and supporting them, because in the end of the day, it's about total cost of lifetime, total life cycle cost. And a lot of people don't take that into consideration. Like, for instance, if you have let's say, poultry slaughtering house or a mill or something, what does it cost the mill to stand for a week or a month?
Yeah.
Instead of putting in something that is highly reliable and strong and that you can depend on, you now bought something that's cheap and nasty.
Yeah.
So that's why reliability in switchgear is extremely important. And then obviously the speed that it works on, the faster it can break that fault, the lower the impact is on the network and on the people for that fault. So I've seen some of switchgear that works so fast that even if there was an arc flash, it was so fast and so small that you could literally clean off what was causing it, test, and then switch on again in a lot of cases. So yeah, fast switchgear is always better.
Okay, great. So Eben, I need MV Switchgear. Where do I start?
Okay, so firstly, you need to understand what load are you going to feed. Is it going to be a mini sub? Is it going to be a primary sub? Is it going to be some sort of a mill or something with rotational loads? What is the fault rating of that sub, of that line, of the feeding line? And then obviously what is the application? So there would be primary switchgear applications and there would be secondary switchgear applications. And then on top of that, there's also the protection, the kind of protection that you need to take into account. So all of those things are important. When someone comes to me and say, I need switchgear, I would go through a list of questions with them to see what is the story there, what is the kind of scenario, the situation that they find themselves in, and then I would give them good advice to say, I would rather go for this with this kind of relay, and then the people usually get help. We can supply the correct equipment to them. A lot of the times people come and they just ask, give me X. We give them X, but it was not applicable to that specific application. So it's always better to be upfront with what you are going to use it for, and then we can give you proper advice on that.
Okay, great stuff. Well, that's it for today. Thank you for tuning in to our first episode of the year, and then stay tuned for the next one in February. Thank you. Bye.
Thank you.